So what is an x-intercept? An x-intercept is just the point on the x-axis where a function graph passes through it. Now, if you have a function, the x-intercept is where that function is equal to 0. This is because the function is represented by its output, and when the output is equivalent to 0, then that would cross the x-axis. Say you had the function f of x is equal to 7x minus 14. We established that it would have to be equal to 0, so you'd write 7x minus 14 is equal to 0. You add 14 to both sides, effectively moving 14 to the other side. You get 7x is equal to 14. Divide both sides by 7 and you'll get x is equal to 2. Hence, the x-intercept is at x is equal to 2. And here's the graph of it, and you can see that it does cross the x-axis at x is equal to 2. As we've established, however, a parabola is a curve, so it will probably pass the x-axis twice. There are three options. It can have two x-intercepts, it can have one where it only brushes the x-axis, and then it can have no x-intercepts at all. A massive chunk of the whole idea of quadratics is dedicated to finding the x-intercepts. So, as I've mentioned, every quadratic can be written in the form ax squared plus bx plus c. A, b, and c are all variables, and it doesn't matter what they are. This can be any number you think of. The only exception to this rule is a cannot be 0, because then the coefficient of x squared is 0, which just means it's no longer quadratic. To get the intercepts to any quadratic ax squared plus bx plus c, you'd make it equal to 0. Here's what that looks like. Now, this is where the problem arises. In a linear function without the x squared, there's only one x, so it's easy to solve for 0. In a quadratic, it's difficult. Say you have x squared plus 10x plus 15. Now, you can try factor x out. You can put 15 on the other side. It'll take you super long time. Chances are you might just quit before getting there. Now, that's why a formula was made to get the zeros, and this formula is called the quadratic formula. So now that we've established that we're doing this to solve for 0, we can start. There are several ways of deriving the quadratic formula, but I think this way is the easiest to understand. So we start off with ax squared plus bx plus c is equal to 0. Now we're going to multiply both sides by 4a. We know that since you're doing this to both sides, it won't change the value of x. When you multiply both sides by 4a, you're going to get 4a squared x squared plus 4abx plus 4ac. For the right hand side, we know that anything multiplied by 0 is just 0. So now we have this. We're going to put the 4ac on the right hand side, so we're going to subtract 4ac from both sides. Now we have 4a squared x squared plus 4abx is equal to minus 4ac. Here's going to be the most confusing step if you're not familiar with this. I'm going to add b squared to both sides. The reason this works is because it is added to both sides. If I was to bring it back on one side, they'd cancel each other out, meaning they don't actually have an overall effect. It's just kind of the same thing as adding a just 0. So now we have 4a squared x squared plus 4abx plus b squared is equal to b squared minus 4ac. So now the terms on the left hand side can be factorized. In a factored form, our new equation looks like, in brackets, you have 2ax plus b squared is equal to b squared minus 4ac. I'm just going to put this on pause for a second. Say you had x squared is equal to 9. It's important to note that x does have two values. Both negative 3 and positive 3 can be x, since negative numbers squared are still positive. So the notation for this would be x equals plus minus the square root of 9, which is just x equals plus minus 3. The plus minus sign is pretty important because it indicates that it has two x values. Since we've established that the parabola is a curve, there is a possibility that it will have two x-intercepts, which is why the plus minus sign is important. It creates two alternate paths, which you'll have to solve to get both answers. This is going to make more sense by the end of the derivation. Now we can go back to the original formula. Since the left-hand side is squared, we can square root the other side to simplify it. Now it's 2ax plus b is equal to plus minus the square root of b squared minus 4ac. Note the use of the plus minus sign, indicating that it'll have two values. Now we're left with a simple rearranging. After putting the b on the right-hand side, you're left with 2ax is equal to minus b plus minus the square root of b squared minus 4ac, and then you can divide both sides by 2a to get x. So this is the quadratic formula in its entirety. Now I know that this is a mouthful, but it's better for you to memorize this now, because you will have to. That derivation is not completely necessary to know, but if you know it, it does help a lot, because you're going to need those skills later on in math. So now that we've derived the formula, we can put it to the test. Say you have x squared plus 7x plus 10. A is the coefficient of x squared, which is just 1. B is the coefficient of x, which is 7. And c is the one number without x in it at all, which is 10. If you want, we can do the numerator first. Minus b is just minus 7. Inside the square root, you have 7 squared multiplied by negative 4 multiplied by 1 multiplied by 10. We can treat these separately. 7 squared is just 49. You can keep that there. Minus 4 multiplied by 1 is just minus 4. Minus 4 multiplied by 10 is minus 40. Now you can plug it back in. 49 minus 40 is just 9. And we know the principal root, which is just the positive square root, of 9 is 3. So it's minus 7 plus minus 3, all divided by 2a. We know that a is 1. 2 multiplied by 1 is just 2. And so the denominator is 2. Let's do the plus path, say. First, we can do minus 7 plus 3, which is minus 4. Minus 4 over 2 is just minus 2. So that is one value where the expression evaluates to 0, meaning it is an x-intercept. Now we can do the minus value. We do minus 7 minus 3, which is minus 10, over 2, which is negative 5, which means that negative 5 is the other x-intercept. Now, to verify these two values, you can plug them back into the equation, and they both evaluate to 0. There you have it, it's assured. For final verification, we can actually graph this function. It'll look like a parabola, and as we have calculated by hand, the x-intercept points are actually minus 5 and minus 2. Now, I'm going to end the video here, but I'll tell you this. Watch this as many times as you need to, and try to understand the concept. If you're struggling, you can ask me, message me, however you want, I can explain further. But you have to memorize the quadratic formula. It's completely necessary. You will need to know it for some questions where you can't factor out or complete the square would be too difficult. You will need the quadratic formula. And since I'm trying to make this whole series as holistic as possible, I'll be leaving some practice questions on my website. I'll link that down in the description. Do as many as you can, and then you can click the answers for the answers. And also the study notes are in the description for this lesson.